Conversion from one base to another. Hello guys, so we've been running this series on number base, and if you've not seen the other videos on number base, kindly go to our channel or search for the playlist number base and you see all the videos. So in this video we are converting from one base to another, okay, from different base to other base. So let's get started. So here are our questions. Convert the following: A3 base 16 to base 4, 25 to base 6, 1011 to octal, 123 base 6 to hexadecimal, 61 octal to base 2. So these are the questions. Let's dive in and provide the solutions to it. So let's get into our rules. Of course, we always have rules for every conversion that we do. So let's get into our rule. Rule 1, convert the base to base 10. So the first rule, convert the given base to base 10. So the first thing you need to do is to first convert your given base to base 10. Then secondly, convert the base 10 to the required base. Okay, so this is it. So these are the steps we will use to solve this conversion problem. So let's get started with the solutions to these questions. So for number 1, we have A3 base 16 to base 4, right? So another question is, why is there A? Like we're supposed to convert numbers, so why is there a letter there? So this is the reason. In the number base system, A3, this is hexadecimal, right? Hexadecimal is base 16. So this is hexadecimal. And in the number base system, once a number gets to 2 digits, we represent those 2 digits with a letter. Like the 2 digits 1 and 0, which is 10, will be A. 11 will be B. 12 will be C. 13 is D. And 14 is E. So it continues that way down till Z. So once you have 2 digits number in a number base, you represent it with a letter. And this is because if we write 10, 11, this will be assumed to be 1011. Okay, in order to not confuse our numbers, we represent 2 digits numbers with letter, and that's why we have A3 here. So let's work that again. So A3 base 16. First, we'll convert it to base 10. So if you've not seen the video on conversion to base 10, check it out in the playlist. Okay, so converting to base 10, we'll give it power 0 and 1, right? So this is A. A is 10. So this is 10 times 16 to the power of 1 plus 3 times 16 to the power of 0. Now equals 10 times 16 to the power of 1 is 16 plus 3 times 16 to the power of 0 is 1. So this equals 160 plus 3, which equals 163 base 10. Now the next step is to convert this base 10 to base 4. Alright, I'll wipe this off so we can use the space. So changing 163 base 10 to base 4, remember that we use the long division method. So we divide by the base we're converting it to. So we have 4 here. 4 divide 16, it's 4. 4 divide 3, it's 0, remainder 3. Right? 4 divide 40 is 10, remainder 0. 4 divide 10 is 2, remainder 2. 4 divide 2 is 0, remainder 2. So pick from bottom to top, we have equals 2. So this also equals 2203 base 4. Okay, 2203 base 4. Okay, so that's how you convert it. So let's go to the next one too. Convert 25 base 7 to base 6. Right, I'll wipe this off. So the first thing we need to do is to convert 25 base 7 to base 10. So we give them power 0, 1. So this is 2 times 7 to the power of 1 plus 5 times 7 to the power of 0. And this equals 2 times 7 plus 5 times 1. So this is equal 14 plus 5. And this equals 19 base 10. So now we're converting base 10 to base 6, right? So base 6, so to base 6, we'll divide 19 by 6 and write down our remainder. So 6 divide 19 is 3, remainder 1. And 6 divide 3 is 0, remainder 3. From bottom to top, we have 3, 1 base 6. Okay, so that's how we convert this. Next one, say 1011 base 2 to octal. Let's work on that. The first thing we need to do is to convert this binary to base 10, right? So we have 0, 1, 2, and 3. And we have 1 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. This equals 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. And this equals 8 plus 0 plus 2 plus 1. And this is 11 base 10. So next we'll convert 11 base 10 to octal. So we divide 11 by 8. Okay, so 11 here. Okay, so 11 here and 8. So 8 divided 11 is 1, remainder 3. And 8 divided 1, 0, remainder 1. So from bottom to top, we have 1, 3, base 8. So 1, 3, base 8. Alright, so next one says, convert 1, 2, 3, base 6 to, this is 2, must have 1, so hexadecimal. Okay, let's wipe this off. Our first step is to convert 1 to 3 base 6 to decimal. So this is 0, 1, 2. 1 times 6 to the power of 2 plus 2 times 6 to the power of 1 plus 3 times 6 to the power of 0. And this is 1 times 36 plus 2 times 6 plus 3 times 1. So this is 36 plus 12 plus 3. Alright, and when we add them together, we have 51 base 10. Our next agenda is to convert this 51 base 10 to hexadecimal. Hexadecimal is base 16, right? So we divide by 16. 16 divide 51 is 3, remainder 3. 16 divide 3, 0, remainder 3. So this would give us equal to 3 base 16, which is hexadecimal. All right, so that's it for conversion of this. Lastly, 61 octal to base 2. So 61 octal is base 8. So 61 base 8 to base 2. Let's give them power 0, 1. This is 6 times 8 to the power of 1 plus 1 times 8 to the power of 0. This equals 6 times 8 plus 1 times 1. This equals 48 plus 1. And this is 49 base 10. Our next agenda is to convert this to base 2. So 49 divided by 2. 2 divide 4 is 2. 2 divide 9, 4, remainder 1. 2 divide 2, 1. 2 divide 4, 2, remainder 0. 2 divide 12, 6, remainder 0. 2 divide 6, 3, remainder 0. 2 divide 3, 1, remainder 1. 2 divide 1, 0, remainder 1. So from bottom to top, we have 1, 1, 0, 0, 0, and 1 base 2. So this is it for conversion from one base to another. From here, we've established that the first thing we do is to convert that base to base 10 by multiplication and convert the base 10 to the next base by division. We divide the base 10 number by the base we're converting it to, and then we have our answers. Don't forget to subscribe to our channel, like, comment. If we are doing well, drop a comment. If we're not doing well, drop a comment on where you think we should improve, and we will improve. See you in the next video.